Hello everyone. This is Unit 2-1 and we're going to talk about multiple representations. So the topic is multiple representations. Now the essential question for these notes, so by the end of these notes you should be able to tell me, okay, how do I represent information in multiple ways? You should be able to answer that by the end of these notes. How do I represent information in multiple ways? Alright. So if you were in class, you would have noticed that we did the 4 scenarios and the different type of ways to represent information. So just like how you have a mom, but she's not just your mom. She could be somebody's sister, somebody's daughter, somebody's granddaughter, and so on. There's different multiple ways to call the same person, right? Different representations. Same thing with math. There are different representations for the same type of data, and there's always benefits to one way to present this information, one way to do this representation. There's benefits to this and there's benefits to that. So there's multiple representations, all for the same data, okay? And we're going to figure out which ones to use and when. So if you look at the first representation, it's listed as a set of ordered pairs. So let's highlight that. Ordered pairs, okay? Ordered pairs are just your points, your coordinates, all in a list. They're pairs of numbers, your x, your y. So the keyword there is, I give you a sample here. What does that representation communicate? So what does it communicate? So if you look at it, all it simply communicates is it's a list, okay? It's the list of values. Your x's, your y's, your domain, your range. It's simply just a list of values. So if you wanted to know, what the points are in a list, this is the perfect representation for it. It's all there for you in a list. With the table, okay, now we're talking about table. Now it looks like a list as well, but it is separated x and y, going from top to bottom down. So it is a list, but not just a list. It's a structured list. And structured, you can just think of like, say, a building, a structure. It's a uniform. It's built in a certain way. The way this table is built, you can see your x's, your y's. It's built a certain way. It's structured. So it's a structured list. Okay, the points are not just listed for you, but it's in a way where you can easily see the x's together, the y's together. X's to the left, y's to the right, independent variables to the left, dependent variables to the right, and so on. The equation. Now the equation, y equals 5x, it's something we're used to looking at. You can solve for x's, okay? You can solve for any number of x. So it's not just certain points, certain tables in a list, but more of a generalization. It's in general, if for any x you plug it into the equation, what y would you get? So input, output. If you put something in, you get one value. So it's a generalization. So I'm going to write generalization. And just so you remember, all that means is for any x. So any x you plug in general, this is what you'll get, okay? So if you want to solve for an x, plug in y, that's what the equation's for. It's not a list. You won't have your x's from 0 to 5, whatever. It's just the one value, okay, one input gives you one output. Generalization. For mapping, now if you think of a map, okay, maps are your two ovals with your lines showing direction. When you look at a map, you start somewhere, you go towards a destination. So you're looking, to find your way to wherever you're trying to go, right? It shows direction. So as a map, okay, it's showing, okay, corresponding values, okay, which are your domains, which is also your x, okay? If you don't remember, domain is x. To multiple ranges, okay, multiple range, which is also your y. So if you notice from the map here, right, you say it is a map, you start somewhere. Like if I start at 1, where does it go towards? It goes to 7. 1 maps to 7. So every time you put the x of 1, it gives you a value of 7. Okay, but that's not all it does. If, say, you went to 2, okay, let's just erase that. So if you start at 2, you're mapped to 8 as well. So if you start at 2, you go to 8. You start at 2, your destination would be 8. If you start at 3, your destination would be 8 as well, right? But there, you see how there's multiple ranges? You can end up in the same spot. You can start somewhere, you can end up in the same spot, right? So it just shows a map, it shows direction, and it tells you that you can go to multiple Y's, so multiple ranges, right? It's just showing corresponding values, but it shows from what to the next, okay? Now on a table, like it kind of looks like a table, but here you wouldn't list multiple Y's. You see how 8 is only listed once. So when mapping, you only see one value one time on the right, okay? But multiple values can be mapped to it. On a table, you'll see 8 repeated, or you'll see multiple numbers on the right, different Y's. That's what this is useful for. It'll take away those multiple values, and you'll know what my Y values are, just 7 and 8. Even though 8 may be repeated, but the good thing about mapping is you know that the only values are 7 and 8. All right, you can tell your range is 7 and 8. Even though 8 or any number could be shown multiple times, you know the only values you'll get for Y are 7 and 8. So, excuse me. So now if I have a graph, okay, graph are your points plotted, and usually you look at a graph to notice the relationship, kind of tell what's going on. You look for, okay, trends. And trends mean if something is trendy, you'll notice, like say this nice hat is trendy. Okay, that means more people will wear that hat. Okay, it's going to increase. You notice the plot points are going up, right? But say the hat is no longer trendy, people found a new fashion trend, so the plot points will go down. It's decreasing. That's what you're looking for. You're looking for that pattern, like is it going up? Is it going down? What's happening to this data, right? You look for trends. Not only trends, you also look for clusters, like say grouping, right? Are these plot points grouped towards an area? Like, is it closer around this area? Is it closer towards the end? Where is it grouping up together, right? So that's useful information. Like maybe most people in this classes are saying like the age of 14. You'll see a lot of plot points at 14. There might be the kid that's 16, 17 out here. It depends. You look for clusters, right? That's valuable information. So if somebody ever asks you like, what does this data tell me? Like, or what is the general age, what is the average, you'll notice it's kind of towards this area because it's more grouped there. It's clusters. Clusters are just groups. All right, now here's the definition of a function. Okay, this is the main definition. A function, I'm going to highlight some keywords. Function, it's a relation. Relation is just comparing two things where each value from the first set, which is just the domain, first set. So like when you have your list, you have your x's, the first side of the table, x's, y's, is mapped to exactly one value. Okay, that is important. Exactly one value in the second set, which is also your range. If you don't remember, domain is x, range is y. Now I highlight those keywords, but let's make this simpler for you. Okay, and I'm going to draw a star, and let's say, okay, a function is, in simple terms, every, okay, and we said domain, every domain, let's just say every x is mapped to only one, right? So every x has only one y, okay? Every x has only one y. So keep that in mind. If I go to the ordered pairs here up top, okay, you see this x is a 0, 1, and there's another 1, there's another 3. So do you notice how there's two x's, two 1s mapped to different values? So no, that first example would not be a function, right? You see two 1s, but it's mapped to both a 2 and a 5. So if you input a 1 for x, you can get a 2 and a 5. That's not a function. If you look at this table, right, you have a 0, a 1, a 2, right? They're all different with different values, okay? One way to look at a table, if you see the x repeating, that's not a function. In this case, it is a function because every time you put in a 0, you get a 5. Every time you put in a 1, you get a 6, 2, 7, right? There's not multiple x's to different y's. Okay? And a function is just a function. We'll leave that alone. But again, to the map, right? You see the 1 on the x. It goes to only a 7. 2 only goes to 8. 3 only goes to 8. So yes, that is a function. Even though you see how 2 numbers go to the 8. If you input a 2, you get an 8. If you input a 3, you get an 8. That's fine, right? Every x has only one y. It doesn't say every y. Okay, it doesn't say every 8 has only one x. Okay, every y value can have multiple x's, but as long as every x is only mapped to one y, okay, it only goes out one direction. The 2 cannot go to the 7 as well, and the 8, it only has one direction, one map to only one. Okay, and with the graph, the easiest way to tell if it's a function, if there are multiple x's, it's called the vertical line test. So if you notice here, if you draw down, right, 2 x's, okay, say this is a 3, it's mapped to both these values here for y, okay? That's not a function. All right, that's one way to check for graph. So that's the main thing about a function, is every x has only one y. And this last part here, you would have to do the assignment in class to get this, but we'll stop there with these notes, okay? So we talked about the main multiple representations, these 5 different ways, and if it's a function, if every x has only one y. That would be it for Unit 2, Section 1, Multiple Representations.